some remarks. We have seen actually yesterday if W is a subspace of vector space V. So we have seen that dimension of W is always less than or equal to dimension of V, and in particular, dimension of W is same as saying the dimension of V that the subspace is itself. We have seen yesterday. And continuation to this, suppose you have two subspaces W1 and W2, two subspaces of a vector space V. Then automatically, so look at the idea. W1 intersection of subspace is again a subspace, right? This is subspace of W1 as well as W2. So therefore, by this idea, dimension of W1 intersection W2 less than or equals to dimension of W1, and dimension of W1 intersection W2 is always less than or equals to dimension of W2. So therefore, this is actually what lower bound for the set. Which set? Dimension of W1, dimension of W2. So for this set, this is a lower bound. This one is a lower bound. Therefore, we can have a greatest lower bound. That greatest lower bound is always bigger than or equal to this lower bound. But greatest lower bound of this finite set is nothing but a minimum. You know in real analysis. So that is a minimum. Minimum is always less than or equal to greater than or equal to lower bound because it's the greatest lower bound. Therefore, dimension of W1 intersection W2 is less than or equal to dimension of W1 plus dimension of W2. Suppose you are asked to compute what is the upper bound for what is the largest value of dimension of W1 intersection W2. Whenever such a question you are asked to find, what you do is that you take minimum of dimension of W1 and dimension of W2, compute it, and that is what actually upper bound for dimension of W1 intersection W2. Right, this is what actually one. Similarly, dimension of W1 plus W2 is nothing but what? Dimension of W1 plus dimension of W2 minus dimension of W1 intersection W2. Right? Again, you know that this is always a subspace of V. Therefore, dimension of W1 plus W2 always less than or equals to dimension of V because it's a subspace of V. Right? So therefore, dimension of W1 intersection W2 always less than or equals to, right? Not less than or equals to dimension of W1 plus W2 dimension of W1 intersection W2. This is greater than or equals to dimension of W1 plus dimension of W2 minus dimension of V. Right? This is what my lower bound for W1 intersection W2. Therefore, this using 1 and 2, this is dimension of W1 plus dimension of W2 minus dimension of V is always less than or equals to dimension of W1 intersection W2 plus minimum of dimension of W1 dimension of W2. So this is what very, very important, right? So suppose you are asked to find upper bound for this. So this is a bound. Suppose you are asked to compute lower bound for this. What is the least value of this? Means you need to find lower bound. Similar argument for W1 plus W2. W1 is a subspace of, W1 plus W2 is the smallest subspace of V containing each of the subspace we have seen. And similarly, W1 plus W2 is the smallest subspace which is containing each of them. So by using the same formula, this dimension of W1 always less than or equal to dimension of W1 plus W2 is the dimension of W2 is always less than or equal to dimension of W1 plus W2. Again, you know that this value is an upper bound for the set. What set? Dimension of W1 and dimension of W2. For this set, this is an upper bound. This is a finite set. Therefore, automatically least upper bound is always less than or equal to upper bound. But least upper bound for this set is nothing but actually maximum because it's a finite set. Right? So therefore, this is what actually least upper bound for that. Right? This is W1 plus W2. So this is W1 plus W2. Similarly, this is what actually using. This is 3. Similarly, dimension of W1 plus W2. Dimension of W1 plus W2. Suppose you are asked to find upper bound for this. This is nothing but what? Dimension of W1 plus dimension of W2 minus dimension W1 plus W2, always less than or equals to dimension of V. Is it audible? Is it audible, sir?
Yes, sir.
Yeah. So therefore, using these two relations, dimension of W1 plus W2, it's a lower bound for this, the same strategy. So lower bound is always, less than or equals to greatest lower bound of this set, but the greatest lower bound of this set is nothing but minimum of dimension of W1 plus dimension of W2, comma dimension of V. So therefore, using this 3 and 4, one can, write like this. So maximum of dimension of W1 comma dimension of W2 is always less than or equals to dimension of W1 plus dimension of W1 plus W2 less than or equals to minimum of dimension of W1 plus dimension of W2 comma dimension of V. So this is what important formula. Suppose you are asked to find mean upper lower bound for this. What is the lower bound? Maximum dimension of W1 comma dimension of W2. Suppose you are asked to find upper bound for this. Dimension of W1 plus dimension of W2 comma dimension of V. Yeah. Using these two ideas, suppose your problem. Suppose V and W, V2 subspaces of R5 with the condition dimension of V is 3, dimension of W is 3. So which of the following is true? First one, we always have V1 plus W is equals to R5. Second one, we never have V plus W is equals to R5. Third one, we must have dimension of V intersection W is always bigger than equals to 1. Fourth one, if V plus W is R5, then dimension of V intersection W is equals to 2. It's a options, but what you are given is that you are given that the V and W are subspaces of R5 with the dimensions 3. With the dimensions 3. So V is a subspace of R5. Similarly, W is a subspace of R5 with the dimensions 3. Right? We always have V plus W is equals to R5. This is absolutely wrong because I'm going to take ABC with the dimension 3 such that A comma B, BC belongs to R. We know it is a subspace. It is a sub. Is it audible, sir?
Yes, sir. Okay.
Yes, sir.
Yes,
Okay,
sir.
my power is gone actually. Okay. Current table. Okay. So it's a subspace of R5. Look at the free variables 3. So dimension of V is 5. Dimension of V is 3. Okay. Suppose you can consider W to be V. Again, what is my W? My W is also V. Right. So therefore, similarly, dimension of W also 3. So satisfying this condition. But what happened? V plus W is equals to, whenever these two are subspaces, V is not W is nothing but again V. Whenever V is a subspace, V plus V is equals to V, you have seen. But V is not never equals to I here. Because actually, free variables here 3. In R5 dimension is 5. In V dimension is 3. Therefore, V cannot R5. Yes or no? V cannot R5. Why? Because dimension of V is 3. Your dimension of R5 is 5. Therefore, V cannot R5 using this property. So using this first property. So V W equals to V for only if the dimensions are same over the same field. right? So first condition fail, right? We always v plus w is equals to r5 is wrong, right? What is second phi? We never have v plus w is equals to r5. This is also wrong. Suppose you take this v is equals to abc 0 0 0, such that abc are real numbers. W is equals to, you can take I need to have r5. You need to fail, you need to give an example which fails. So therefore what you give is 0 0 alpha beta gamma, such that alpha beta gamma belongs to R. They are subspaces with the dimensions 3, because free variables 1 to 3, 1 to 3. Okay, so dimension is 3. Okay, so condition is satisfied, hypothesis is satisfied. Okay, now look at v plus w. What is v plus w? A plus 0 A, b plus 0 b, c plus alpha, next 0 plus beta, next 0 plus gamma, such that abc alpha beta gamma belongs to R. Question is, can you write v plus w is equals to r5? Is it possible? So always, this is always subset of this. It's a subspace, because sum of subspace is again a subspace. Finite sum of subspace is again a subspace. This is always true. Question is, this is true. V plus w is r5 is contained in v plus w. Is it true? So look at the idea. Suppose you take any random vector a, b, c, d, e in r5. The thing is, I can write this, a, b, c, d as a, b, keep it as it is. See, what is meant by v plus w? Third vector can be written as a sum of two real numbers. C alpha, sum of two real numbers. So C can be split in so many ways, of course. C can be written as like this, C minus 1 plus C, D, E. Therefore, third vector is split into two real numbers. Therefore, which is in v plus w. Therefore, any vector that you started with in R5, that is in v plus w. Therefore, R5 is contained in v plus w. Therefore, this v is equals to r5 is equals to r5 is equals to v plus w. So in this situation, r5 is equals to v plus w is possible. So therefore this is wrong. Actually, we never have this is wrong, because possibility is there. We must have dimension of v intersection w is greater than or equals to 1. Is it true? We must have dimension of v intersection w is greater than or equals to 1. Means you need to find a lower bound. What is the lower bound? Dimension of v intersection w is always greater than or equals to maximum of, what is it? What is the lower bound? What is the lower bound for this? You can use this formula. What is the lower bound? Dimension of w1 plus w2.
Dimension of v
Dimension of w1
plus dimension of v2 v
minus r5, means dimension of r5 is 5. But what is this? 3 plus 3 minus 5. What is this? 1. Therefore, dimension of v intersection w is always bigger than or equals to 1. This is possible. This is possible. So this is the right answer. Next, whenever v plus w is r5, whether dimension of w intersection v is it 2 or not, you need to check it. Suppose v plus w is r5. So when the two spaces are equal to the same field, when the two, this is subspace, this is subspace, this is vector space, this is vector space. Two vector spaces are equal if only the dimensions are there over the same field, right? But dimension of v plus w is nothing but dimension of v plus dimension of w minus dimension of v intersection w. But this is nothing but r5. Dimension of r5 is r5, but this is 3. This is 3. So this is as it is. Therefore, dimension of v intersection w is nothing but, what is this? 6 minus 5. Yes or no? What I require to find? I require to find, this is 2. What is this? This is 2. But what you are getting? This is 1. This cannot be 2. So wrong. So here v plus w is r5. Once you take dimension of v intersection w is 1, which cannot be 2. Therefore, this answer also right. Wrong. Is it clear?
Sir, third option malak sir cheppandi sir.
So dimension of V intersection W, what is the lower bound for that formula? What is this? Where is this? Yeah, here. So this is a formula you need to keep in mind. This is a formula actually. Mean lower bound for this is nothing but dimension of V plus dimension of W minus dimension of vector space R5. Right? But what is this? This is 3. This is also 3. This is 5. 3 plus 3 minus 5. That is 1. Is it right?
Okay, sir. Thank you, sir.
So you should keep in this formulas. These are very, very important. These are very, very, very important. Right? Keep in this. Okay. Next one is very important. Again, this is also very, very important. This question asked in CSIR, problem number 2, using the same technique. Let this question asked in CSIR, previous paper. Let S and T be two subspaces of R24 such that dimension of S is equals to dimension of S is equals to 19 and dimension of T is equals to 17. First one, which of the following is true? Smallest possible value of dimension of S intersection T is equals to 2. Largest possible value of dimension of S intersection T is 18. C. Smallest possible value of dimension of S plus T is 19. Largest possible value of dimension of S plus T is 22. Yeah. So again, directly you can use the formula. So what is the formula? So dimension of S intersection T. So this is what actually minimum of dimension of S, dimension of T. This is an upper bound. What is the lower bound? What is the lower bound? Dimension of S plus dimension of T minus dimension of R4 24. So 24. So therefore, minimum of this is nothing but minimum of dimension of S is nothing but 19. This is nothing but dimension of T is nothing but 17. Therefore, minimum of 19, 17 is 17. Therefore, upper bound is 17. Therefore, largest possible, understand, largest possible, value is 17. It could not be actually 18. Understand? 17 కంటే తక్కువనే ఉండాలి. 17, 16, 15 ఎంతైనా ఉండొచ్చు. బట్ లార్జెస్ట్ ఎంత? 17. సో ఇది 18 అని ఇచ్చాడు కాబట్టి ఇది దిస్ రాంగ్. సో మినిమం ఎంత అయితే చూడండి. వాట్ ఇస్ ద స్మాలెస్ట్? This is 19 plus 17. This is 19. This is 17 minus 24. So 36 minus 24. What is that? 12. So least upper bound means smallest value. ఎక్కడి నుంచి స్టార్ట్ అయితే 12 నుంచి స్టార్ట్ అయితే 12. It could be 13. It could be 14. But least ఎంత? 12. Yes or no? But ఇక్కడ ఇచ్చింది ఎంత? 2 ఇచ్చింది. Yes or no? So this is also wrong. కదా? Next. Dimension of S plus T. What is the formula? Dimension of S plus T is always less than or equals to minimum of dimension of S plus dimension of T, comma dimension of vector space. What is my vector space? R4 24. Therefore, this is minimum of, what is this? 24. What is this amount? 19 plus 17.
19, 17, 24.
24. That means 24. What is the lower bound?
20.
Maximum of dimension of S, dimension of T. But this is maximum of 19, 17. This is nothing but what? 19. So what is the lower bound? What is the smallest value?
19.
19. This answer is right. Smallest value of dimension of S plus T is 19. This is right. What is the largest value?
24.
You are getting 24, but the answer is 22. This is also wrong. So this is a very important question. Okay. CSR. This question asked in CSR. Again, this question asked in CSR 2016 in December, let W1, W2, W1, W2, W3 be three distinct subspaces. Of R10 such that ఇక్కడ ఎప్పుడైతే గుర్తుపెట్టుకోండి, ఎప్పుడైతే ఈ డిస్టింక్ట్ వస్తుందో యూ షుడ్ బి వెరీ కేర్ఫుల్. సో ఇంతకుముందు ప్రాబ్లం లాగా చేసిన తర్వాత రెస్ట్రిక్షన్ ఇది అనమాట. ఇది రెస్ట్రిక్షన్ అగైన్ ఫిల్టర్ చేయాలి ప్రాబ్లమ్ ని. ఈ ఫార్ములా యూజ్ చేసి అగైన్ మళ్ళీ రెస్ట్రిక్షన్ కండిషన్ యూజ్ చేయాలి. రెస్ట్రిక్షన్ డిస్టింక్ట్ సబ్ స్పేసెస్. సో కాబట్టి చాలా కేర్ఫుల్ ఉన్నారు. సో సబ్ స్పేసెస్, సబ్ స్పేసెస్ ఆఫ్ R10 such that each double I has a dimension 9, let W is equals to W1 intersection, W2 intersection, W3. So which of the following is true? Then we can conclude that which of the following is true? First one, W may not be a subspace. Of R10. Second one, dimension of W is always less than or equal to 8. C. Dimension of W is always bigger than or equal to 7. D. Dimension of W is always less than or equal to 3. What you're given? W1 is a subspace of R10. W2 also subspace of R10. W3 also subspace of R10 with dimensions. Dimension of W1, dimension of W2, dimension of W3 is equals to 9, but they are distinct. Dimensions same అయితే subspaces same కానవసరం, ఇక్కడ కానవసరం లేదైతే మెన్షన్ చేశాడు. Understand? With the distinct dimensions, but the thing is different. Understand? So therefore, these are the conditions you are given, right? So first question, look at the first question. What is my W? Actually, my W is W1 intersection W2 intersection W3. First question, look at the first option. W may not be a subspace of R10. This is absolutely wrong because we have seen arbitrary intersection of subspaces again a subspace. Any arbitrary class of subspace is again a subspace. Arbitrary intersection of subspace is always a subspace. Therefore, this is wrong because W1 is subspace, W2 subspace, W3 subspace. Intersection of subspace is again a subspace. So you are given actually W may not be subspace. This is absolutely wrong. W is always a subspace. Right? Now, next, look at the second option. Dimension of W less than or equals to 8. You need to find upper bound for W. So dimension of W, what is the dimension of W? W1 intersection W2. What is W? W1 intersection W2 intersection W3. But W1 intersection W2 intersection W3 is a subspace of W1 intersection W2. Therefore, this is always less than or equals to dimension of W1 intersection W2. Why this is possible? Because W1 intersection W2 intersection W3 is always subspace of W1 intersection W2. But again, dimension of W1 intersection W2 is nothing but what minimum of dimension of W1 dimension of W2. But this is nothing but minimum of 9,9. Minimum of 9,9 is 9. But what your option is 8. Again, you can use this condition. What are the possibilities? Dimension of W less than or equals to 8. So what are the possibilities? It can be 1, it can be 2, it can be 3, it can be 4, it can be 5, it can be 6, it can be 7, it can be 8, it can be 9. Question is 9 8 దా కదా చెక్ చేయండి, ఎందుకంటే ఇక్కడ ఆన్సర్లో ఏముంది 8 ఉంది. సో 9 8 దా కదా చెక్ చేయండి. If it is 9, dimension of W is 9. Therefore, dimension of W is equals to dimension of W1 is equals to dimension of W2 is equals to dimension of W3 is equals to 9. Therefore, all are subspaces with equal dimensions. Therefore, by property 1, W1 is equals to W2 is equals to W3, which is absolutely contradiction because you are given the distinct subspaces. Therefore, this is not possible. Dimension of W cannot 9. Therefore, dimension of W less than 9. Therefore, dimension of W less than or equals to 8. So, therefore, dimension of W is less than or equals to 8 is the right answer. And look at the, what is this? This is greater than or less than or? Sorry, this is greater than, this is less than or equals to this is also wrong, right? Because ఇది తీసుకున్నారు అనుకోండి, ఇక్కడ 8 మిస్ అయిపోతుంది. అర్థమవుతుందమ్మా? ఇది రాంగ్. ఎందుకు? ఇక్కడ పాసిబిలిటీస్ ఏంటి? డైమెన్షన్ ఆఫ్ డబ్ల్యూ ఏం కావచ్చు? 1 2 3 కావచ్చు. ఇక్కడ పాసిబిలిటీస్ ఏంటమ్మా? 1 2 3 4, బికాస్ 0 కూడా కావచ్చు. సో 1 2 3 4 5 6 7 8 కావచ్చు. ఇక్కడ నువ్వు ఈ ఆప్షన్ చూస్ చేసావు అనుకోండి, ఇక్కడ 8 మిస్ అవుతుంది, 7 మిస్ అవుతుంది. కాబట్టి ఈ ఆప్షన్ రాంగ్ కదా. సో therefore next, see, look at the C option. What is C option? You need to find the lower bound. How to find the lower bound? Dimension of W is always, what is this actually? Actually, this is nothing but dimension of, you need to write like this. So dimension of W is nothing but dimension of W1 intersection W2 intersection W3. But what is the lower bound? Lower bound is dimension of W1 intersection W2 plus dimension of W3 minus dimension of my vector space. What is my vector space? 10, R10. So therefore R10. But this is nothing but dimension of W1 intersection W2 plus dimension of W3 minus 10. Okay. But the thing is, what is the lower? See, you need to find the lower bound for this. So it's enough to find the lower bound for this, because you are already given what you are given. Dimension of W2 W3 is nothing but 9. Understand? So therefore it's enough to find the lower bound for this. But what is the lower bound for this? Anybody? What is the lower bound? Dimension of W1 plus dimension of W2. What is the lower bound for this?
Dimension of R10 minus 9. Nine plus 9 minus 10, that equal to 8.
So therefore, what is this? This is 9 plus 9 minus 10. 9 minus 10. What is this? 27 minus 20. Therefore 7. So what is that? 7 is a lower bound. 7 is a lower bound. So this answer is right. So this is the way you need to filter the options. Okay. So this is very, very important technique to find the dimension. Okay. Next, what you have seen till now? Till now we have seen that n tuples. Till now we have seen that n tuples over C, and with the different restrictions. Next is next example. Suppose my vector space is matrices, m by n matrices. This is my vector space over a field R. So what is the dimension? What is the basis? Yeah. What is the dimension? What is the basis? Anybody? You have seen, right? What is a, suppose you take any matrix. What is the form of this? A11, A12, A1n, A21, A22, A2n, AM1, AM2, AMN. Therefore, how many free variables are there? These are all free, right? How many total variables? These are all free. So therefore, what is the dimension?
M into N.
M into N. Because the field is same. You need to observe that the field is same. Entries are real, field also real. Therefore, there is no problem. What is the basis? Basis means, suppose you take A11 is equals to 1. Remaining variables are 0. That we call it as E11. Suppose you take A12 is 1. Remaining, what is E11? E11 is nothing but first entry is 1. Remaining entries are 0. What is E12? Second entry is 1, 2 entry is 1. Remaining entries are 0. It's 1, 3. Going on. This is my basis actually. Ej such that I running from 1 to m, j running from 1 to m. So this is my basis. Suppose the same example, if you take this set of all matrices, real matrices over a field complex numbers, what is the dimension? Yeah. What is the dimension? What is the dimension? Anybody? Cannot be defined, right? It's not a vector space.
Yes.
Right? Because once you multiply with a complex number, it cannot be in V. Understand? Suppose you take I into suppose 1, 2, 3, 4. So therefore, the entries which are not real entries, the entries which are not real entries, therefore it does not belong to V for 2 by 2 matrix. Suppose you consider. So dimension cannot be defined. Right? Suppose you take n by n or C. My field is C. What is the dimension? What is my basis? Again, same idea. The idea is same. They're using the same technique. M into n, right? That's it. Right? That means the entries are complex entries over the field complex.
Complex.
So therefore, A to n, am1, am2, amn. Therefore, how many free variables? N free variables. Therefore, how many free variables? Mn free variables. So dimension is mn. Because the field and entries and field are same. Entries real complex entries and field also complex entries. So what is my basis? Same. Ej such that I over 1 to n, j running from 1 to n. So this is my basis. Suppose V is my matrices or real field or real field. What is the dimension? What is the basis? Again, we are working with the two, the entries are complex scalars, field elements are real scalars. Again, there is a problem, right? Suppose you start with a matrix which is in V, that is of the form. What is of the form? Complex entries A11 plus IB1, A12 plus IB2, B12, A1n, IB1n. Next A21 plus IB21. Next A22 plus IB22. Going on A2n plus IB2n. Next AM1 IBM1. Going on AM2 plus IBM2. Going on AMN plus BMN. So therefore, how many scalars? How many free variables? 1, 2, 1, 2, 1, 2. So total is actually mn, that is into 2. Mn into 2. Understand? Total entries mn into 2. Understand? Therefore 2 into mn. Because the real entries, how many real entries? 1, 2, 1, n. Next 1, 2, n. N plus n plus n plus n plus up to m times. Therefore m into n. How many imaginary parts? Mn. Mn plus mn is 2mn. So what is my basis? Anybody? My basis is, suppose you put actually A11 is 1, remaining entries are 0. So what is the basis? My basis Aij such that I is running from 1 to m, j is running from 1 to n, union I into Eij. So very notation is coming. You can take different notation because I and iota ante so same aitundi. So R into S, RS, where R is running from 1 to S, 1 to M, S is running from 1 to N. Here I into ERS, such that R over 1 to M, S over 1 to N. Is it clear? Because same strategy, A1 1 తీసుకోండి, మిగతా అన్ని 0 తీసుకోండి. నెక్స్ట్ A1 1 తీసుకోండి, మిగతా అన్ని 0 తీసుకోండి. అప్పుడు ఏమొస్తుంది మీకు ఇది వస్తుంది. నెక్స్ట్ B1 1 తీసుకోండి, అప్పుడు ఏమొస్తుంది I B1 1 తీసుకుంటే ఏమొస్తుంది I 0 0 0 0 0 0 0 0 0 0 0. దట్ మీన్స్ వాట్ I into E1 1. నెక్స్ట్ B1 1 తీసుకోండి, అప్పుడు ఏమొస్తుందమ్మా ఇక్కడ 0 వచ్చి ఇక్కడ I వస్తుంది. Is it clear? So this is my basis. Okay, again you can have restrictions. Next, restriction problem. These are the basic problems. Next is restriction. Next is restrictions. Suppose V is my vector space. This what is my vector space? Suppose you take this Aj Mn cross set of all matrices over the complex field such that summation Suppose you can take this strategy. First row sum is 0. First row sum is 0. My field is complex field. Anybody? What is the dimension? What is the basis? So already I told you what is the total number of variables? Mn. How many conditions? What is the basic variable? Only one basic variable. So one condition is there. So what is the dimension? Total variables Mn minus one condition, one restriction. Therefore Mn minus 1. Is it clear? Or else you take any vector which is in V, that is of the form a11, a12 going on a1n, a21, a22, a2n going on am1, am2, amn. Therefore, you need to replace a11 by minus of a12, minus of a13, minus of a1n, next a2, a12, a1n, next a21, a22, a2n, going on, am1, am2, amn. Right? So how many free variables? Anybody? How many free variables? Mn minus 1. Understand? How many free variables? Even in Utayama. Even in Japan. Total any Japan? Total Mn minus 1. ఈ వేరియబుల్స్ ఎన్ని ఉంటాయి చెప్పండి, బ్రాకెట్ లో ఎన్ని ఉంటాయి చెప్పండి, ఇవే కదా ఫ్రీ వేరియబుల్స్. ఇవన్నీ రిపీట్ అయినాయి, ఇవి రిపీట్ అయినాయి ఆల్రెడీ కదా. సో ఈ గివ్ ఎన్ని ఉంటాయి చెప్పండి, ఇవి ఎన్ని ఉంటాయి, ఇవి ఎన్ని ఉంటాయమ్మా, total minus 1. Understand? Total any Mn minus this one. This is one element. So therefore dimension is Mn minus 1. Is it clear? See, geometrical view అర్థం చేసుకోండి, then only we can easily answer. Otherwise మీరు సో మగప్ చేస్తే మాత్రం ఏం రాదు. ఎందుకంటే ప్రాబ్లం వెరైటీ వస్తా అంటే ఎంట్రన్స్ వల్ల. మనం జామెట్రీ పాయింట్ ఆఫ్ లో ఆలోచిస్తే ఈజీగా ఉంటుంది సబ్జెక్ట్. ఓకే, వాట్ ఈస్ ద బేసిస్? చెప్పాను మరి టెక్నిక్ ఏంటి. టెక్నిక్ ఏం చేస్తారమ్మా, a11 బేసిక్ వేరియబుల్ కదా. సో మీరు ఏం చేస్తారు, a12 1 చేస్తారు, మిగతా 0 చేస్తారు. నెక్స్ట్ a13 1 చేస్తారు, మిగతా 0 చేస్తారు. a11 1 చేస్తే ఏమైంది, దిస్ ఇస్ 1, దిస్ ఇస్ -1, 0 0 0 0 0 0 0 0 0 0 0 0. నెక్స్ట్ ఏం చేస్తారు, a13 1 చేస్తారు, a13 1 చేస్తారు, మిగతా అన్ని 0 చేస్తారు. a13 1 చేస్తే ఏమొస్తుంది, ఇది 1, ఇది 0, ఇది -1, 0 0 0, నెక్స్ట్ 0 0 0 0 0 0, ఇట్లా చేసుకుంటే అనుకుంటాను. అండర్స్టాండ్? సో దిస్ ఇస్ -1 0 0 0, లాస్ట్ ఎలిమెంట్ ఏమొస్తుంది, -1 0 0 0 0 0 0, going on 0 0 0 0 1. This is my basis. Is it clear? So this is restriction. Row sum is 0. First row sum is 0. Suppose ఇదే ప్రాబ్లం నేను కొంచెం చేంజ్ చేశాను. సెట్ ఆఫ్ ఆల్ మ్యాట్రిసెస్ ఫర్ ఎ ఫీల్డ్ ఆర్, సెట్ ఆఫ్ ఆల్ మ్యాట్రిసెస్ ఫర్ ఎ ఫీల్డ్ ఆర్ సచ్ దట్, నేను ఇదే ప్రాబ్లమ్ ని రెస్ట్రిక్షన్ నేను ఇంతకుముందు ఓన్లీ ఫస్ట్ రో సమ్ ఈజ్ 0 అని పెట్టాను కదా. ఫస్ట్ రో సమ్ ఈజ్ 0 అని పెట్టాను, a11 ప్లస్ a12 ప్లస్ a1n ఈజ్ 0 అని పెట్టాను. సిమిలర్ గా నేను ఏం చేస్తానంటే 2 row sums are 0. 2 row sums are 0 for I equals to 1 to 2. My field is complex field. Yeah, what is the dimension? Anybody?
Mn minus 2.
Mn minus 2. Good. Total minus how many conditions? 2 conditions, 2 restrictions. So Mn minus 2. Suppose my vector space is space of all Mn, space of all M by N matrix over field C such that each row sum is 0. For each row sum is 0. Each row sum is 0 for a complex field. What is the dimension? Yeah, tell me. Total minus Mn minus M. Good. Suppose this problem నేను యాక్చువల్గా కాంప్లెక్స్ ఫీల్డ్ కాకుండా రియల్ ఫీల్డ్ తో చేస్తాను. ఏమైనా చేంజ్ ఉంటుందా? ఫస్ట్ ఒకటే తీసుకోండి, మీకు ఈజీగా ఐడియా వస్తుంది. సో 1 రో సమ్ ఈజ్ 0. ఫస్ట్ రో సమ్ ఈజ్ 0 ఓవర్ ఏ రియల్ ఫీల్డ్.
n square minus 1.
ఆలోచించండి. ఓవర్ ఏ రియల్ ఫీల్డ్. ఓవర్ ఏ ఫీల్డ్ మై ఫీల్డ్ ఈజ్ రియల్ బట్ ద ఎంట్రీస్ ఆర్ కాంప్లెక్స్ ఎంట్రీస్.
2 into mn minus 1.
యా 2 into mn minus 1. బట్ ఎందుకు ఇక్కడ స్ప్లిట్ అయితే ఎంట్రీస్ ఏంటి? స్ప్లిట్ అయితే ఎన్ని కండిషన్స్ వస్తాయి మనకి? 2 కండిషన్స్ వస్తాయి. చెప్పాను ఇట్లాంటి టెక్నిక్. a12 plus ib12. నెక్స్ట్ దిస్ ఈజ్ నథింగ్ బట్ వాట్? a1n plus ib1n. అర్థమైందా? ఓకే, ఒకసారి చూడండి. సో a is a matrix అని తీసుకున్నారు అనుకోండి, n by n. So a is a matrix which is in V అని తీసుకోండి. You can take any element which is in V. What is the form? The form which is in the form is actually the condition it satisfies a11 plus a12 plus a1n is 0. But the thing is a11 is nothing but what? Complex entry. That means it can be rewritten as a11 plus ib1 plus a12 plus ib12 plus a1n plus ib1n equals to 0. That is if and only if real part sum is 0. That means a11 plus a12 plus a1n is 0. Next, b11 plus b112 plus b11 is 0. Therefore, how many conditions? Total how many variables? Mn. How many conditions?
2 conditions.
So restricted into subtract it. So therefore, mn minus 2 is the answer. Is it clear? Yes.
Okay.
బేసిస్ కూడా రాయొచ్చు, ఈజీ. బేసిస్ కూడా రాయొచ్చు. ఎందుకు చేస్తారు? a11 రాస్తారు, మిగతా 500 వేస్తారు. b11 రాస్తారు, a131 రాస్తారు, మిగతా 0 వేసేస్తారు. ఈజీ. బేసిక్ సేమ్ టెక్నిక్.
Sir, 2 mn minus 2 or mn minus 2, sir?
Yeah, 2. Sorry. Good. Yeah, good. So కాంప్లెక్స్ ఎంట్రీస్ ఎన్ని ఉంటాయమ్మా? ఎంట్రీస్ ఎన్ని ఉంటే స్ప్లిట్ అవుతాయి. టోటల్ ఎన్ని? mn into 2. ఏ ఎట్లా ఉంటుంది ఫామ్? ఏ కూడా రాయండి, బెటర్, మీకు ఐడియా వస్తుంది. a11 plus ib11 plus good, a12 plus ib12, a11n plus ib1n. Okay. a11n ib1n. Next, a21 ib12 i21 ib21. Next, a22 ib22. Next, a2n ib2n. Going on, am1 ibm1, am2 ibm2, going on. So n entries in a 2 plus 2m plus 2mn plus mn. Therefore 2mn minus restricted variables. Good. So this is nothing but 2 into mn minus 1. Right? Suppose this problem, set of all matrices or a complex field such that each row sum is 0. Right, my field is R. So field and scalars are different. కాబట్టి actually ఇక్కడ change అవుతుంది argument. So what is the dimension? So total variables. Yeah, tell me, total variables. How many total variables?
Into n minus n.
Yeah, 2mn minus how many conditions? Double అయితే conditions. M ఉంటే
2m.
Yeah, 2m. So therefore 2m minus this n minus 1. M ఉంటే 2m అయితే conditions, because real part తో ఒకటి వస్తుంది, imaginary part తో ఇంకోటి వస్తుంది. Okay. Next, the problem. Set of all n by n matrices for a complex field such that row sum 0, column sum 0 తీసుకున్నాను అనుకోండి. First column sum is 0. Right? That means I1 equals to 0. Yeah, ఏమొస్తుందమ్మా? So my field is complex field. What is the dimension?
mn minus n.
What is my field? My field is complex
Complex.
field. So total, so field same ఉన్నాయి, scalars కూడా same ఉన్నాయి, field same ఉన్నాయి. కాబట్టి total scalars minus condition, one condition. Suppose ఇదే ప్రాబ్లం రియల్ ఫీల్డ్ తో తీసుకున్నాం, ఏమైందమ్మా?
2mn minus
2mn minus 1.
2mn minus any conditions.
minus 2.
Minus 2. Therefore 2 into mn minus 1. Okay. ఇది one row, one column, sorry. One column sum is 0. Suppose నేను each column sum is 0 అని తీసుకుంటాను. Each column sum is 0. I equals to 1 to, see this I equals to 1 to m. So I equals to 1 to m. Aj equals to 0. For each j equals to 1 to m. Yeah. What is my dimension of V? If my field is complex field, what is my dimension of V? If my field is real field. Yeah.
mn minus n m or n.
Mn minus total variables minus how many conditions?
Yeah.
N
Only one
conditions.
condition.
N conditions.
N
Therefore,
condition.
n into n minus 1. Okay. Suppose you take with the real field.
2mn minus
2mn
2m.
minus 2m.
2mn minus ఇక్కడ double అయిపోతాయి.
2n.
2n. So this is what actually happens. Okay. ఇంకో ప్రాబ్లం, row sum columns, each row sum 0, each column sum 0 ఇండివిజువల్ చేసాం కదా. Suppose you take intersection. అంటే each row sum 0, each column sum also 0. You take the intersection. Summation I equals to 1 to m aj is 0. For each j equals to 1 to n. Summation j equals to 1 to n. Aj equals to 0 for each row. Now, what is the dimension? Dimension of V. If my field is complex field, what is my dimension of V if my field is real field? Tell me.
Dimension is 0.
What's the dimension is 0? How?
Sir, mn into minus mn అవుతుంది.
What is the dimension? Restrictions.
Intersections.
So total variables any? mn.
mn.
Restrictions row sum column మీద ఎన్ని ఉన్నాయి? n. Row మీద ఎన్ని ఉన్నాయి? m. కాకపోతే థింగ్ ఏంటంటే మీరు ఇక్కడ అబ్జర్వ్ చేస్తే వన్ థింగ్ యూ నీడ్ టు అబ్జర్వ్ ఇట్.
రైట్.
సో రో సమ్ చేస్తున్నప్పుడు ఇక్కడ ఇది యాక్చువల్లీ ఏమైతుంటది, ఇవన్నీ ఎవాపరేట్ అయిపోతుంటాయి. ఇవన్నీ ఏమని చేస్తాం మనం యాక్చువల్గా డిలీట్ చేస్తూ ఉంటాం. ఇది తీసేసి ఇది రాస్తుంటాం అంతే కదా. రోజు ఇది చేస్తున్నప్పుడు ఈ ఎలిమెంట్స్ అనేది ఏం చేస్తాం, తీసేస్తుంటాం. ఇంతకుముందు ఇక్కడ చేశాను కదా, ఇక్కడ చూడండి, ఇక్కడ ఒకటే రో, ఫస్ట్ రో కాబట్టి ఫస్ట్ ఎలిమెంట్ తీసాను. ఓకేనా, ఫస్ట్ రో సమ్ కాబట్టి ఫస్ట్ రో మీద తీసాను. సెకండ్ రో కాబట్టి సెకండ్ రో మీద ఇస్తాను. ఓకేనా, ఇక్కడ తీసేస్తాను. థర్డ్ రో అయితే థర్డ్ దాన్ని తీసిస్తాను. ఫోర్త్ రో అయితే ఫోర్త్ దాన్ని తీస్తాను. nth రో అయితే nth రో తీసిస్తాను. అంటే ఏంది, టోటల్ కాలం ఎగిరిపోతుంది. సిమిలర్ గా ఫస్ట్ కాలం అంటే ఫస్ట్ రో వెళ్ళిపోతుంది, సెకండ్ కాలం అంటే సెకండ్ రో వెళ్ళిపోతుంది, థర్డ్ కాలం అంటే థర్డ్ రో వెళ్ళిపోతుంది, ఫోర్త్ కాలం అంటే nth రో ఎగిరిపోతుంది, nth రో ఎగిరిపోతుంది. అంటే ఒక ఎలిమెంట్ అనేది మీరు ఇక్కడ అబ్జర్వ్ చేస్తే ఈ ఎలిమెంట్ డబల్ సార్లు డిలీట్ అయిపోతుంది కదా. అర్థమవుతుందా? సో గో బ్యాక్ టు దిస్. ఇక్కడ చూడండి, ఇది ఇంపార్టెంట్ ఐడియా. ఓకే, దిస్ ఇస్ జామెట్రికల్ వ్యూ. ఇప్పుడు మీరు రో సమ్ ఫస్ట్ చేసినప్పుడు ఏమైతే చెప్పండి, ఈ ఎలిమెంట్ ఎగిరిపోయింది కదా, ఫస్ట్ ఎలిమెంట్, ఫస్ట్ రో సమ్ 0 అంటే సెకండ్ రో సమ్ 0 అంటే ఈ ఎలిమెంట్ కదా. థర్డ్ రో అంటే ఇది, nth రో అంటే ఇది. ఓకేనా, ఇప్పుడు ఫస్ట్ కాలం 0 అంటే ఫస్ట్ కాలం 0, ఫస్ట్ కాలం ఈ 0, ఫస్ట్ కాలం సమ్ ఈ 0 అని అనుకోండి. ఫస్ట్ కాలమ్స్ అన్ని 0 అని అనుకోండి. ఇంకోండి m1 ఈక్వల్స్ 0. ఫస్ట్ కాలమ్ సమ్ 0 అంటే ఈ ఎలిమెంట్ మళ్ళీ డిలీట్ అవుతుంది. అండర్స్టాండ్? సెకండ్ కాలమ్ సమ్ 0 అంటే ఈ ఎలిమెంట్ డిలీట్ అయిపోతుంది. థర్డ్ కాలమ్ సమ్ 0 అంటే ఈ ఎలిమెంట్, ఫోర్త్ కాలమ్ సమ్ 0 ఈ ఎలిమెంట్. అంటే ఈ ఎలిమెంట్ 2 టైమ్స్ డిలీట్ అవుతుంది కదా. కాబట్టి ఏంది, యూ నీడ్ టు యాడ్ వన్ మోర్. 2 సార్లు డిలీట్ కావద్దు, ఒక్కసారి డిలీట్ కావాలి కదా. ఒకసారి సర్వైవ్ కావాలి, ఒకసారి సర్వీస్ ఇవ్వాలి, ఇంకోసారి డిలీట్ కావాలి. సో దర్ఫోర్ దిస్ ఇస్ నథింగ్ బట్ మై డైమెన్షన్. సో mn minus, right? So this is what my answer, right? So 2 సార్లు డిలీట్ కావద్దు, ఒక్కసారి డిలీట్ అయితే సరిపోతుంది. సపోజ్ రియల్ ఫీల్డ్ అనుకోండి, 2 తో మల్టిప్లై సరిపోతుంది కదా. Yes or no?
Yes, sir.
Yes. So this is what my answer. Okay, this is very, very important problems. Okay. So next is divisor technique. It is very important. Suppose V is my vector space. set of all matrices for a complex field such that each entry is 0 for whenever I divides n for I equals to 1, 2, 3, 4 up to m. What is my dimension of V whenever my field is complex field? What is my dimension of V whenever my field is real field? Okay, what is that? What is the meaning of this? How many restrictions? అది కదా మనం చూడాల్సింది. టోటల్ వేరియబుల్స్ ఏమన్నాయి, రెస్ట్రిక్షన్స్ ఎన్ని ఉన్నాయి చూడాలి కదా. రెస్ట్రిక్షన్స్ ఎన్ని ఉంటాయి చెప్పండి.
I by m.
డివైజర్స్ ఆఫ్ ఎన్ ఎన్ని ఉంటే అన్ని రెస్ట్రిక్షన్స్ ఉంటాయి. డివైజర్స్ ఆఫ్ ఎన్ ఎన్ని ఉంటే అన్ని రెస్ట్రిక్షన్స్ ఉంటాయి. ఎసాను
Tau of n.
ఎసాను డివైజర్స్ ఆఫ్ ఎన్ ఎన్ని ఉంటే సపోజ్ ఫస్ట్ రో తీసుకుంటారు, I equals to 1 తీసుకుంటారు. ఫస్ట్ రోలో ఎన్ని డివైజర్స్ ఉంటే అన్ని జీరోలు అవుతాయి. సో 1 divides n కదా, 1 divides n. సో therefore these are all zeros. These are all zeros. సెకండ్ రో తీసుకుంటారు, సెకండ్ రోను ఎన్ని డివైడ్ చేస్తారో అది చూస్తారు. సెకండ్ రో తీసుకుంటారమ్మా, సెకండ్ రో తీసుకుంటారు. సెకండ్ రోలో డివైడ్ విత్ ఎన్, ఎన్ని డివైడ్ అయితే అన్ని రెస్ట్రిక్షన్స్ వస్తాయి. అర్థమవుతుందా? ఎన్ని సెకండ్ రో తీసుకుంటారు, ఈ 2 divides n ఇట్లాంటి ఎన్ని ఉంటాయి. సో మనం చెక్ చేస్తాం. సో ఎన్ని డివైడ్ చేస్తే అన్ని ఉంటాయి అనమాట. ఈ ఎంట్రీస్ ఎన్ని డివైడ్ చేస్తే అన్ని డివైజర్స్ ఉంటాయి. సో ఫస్ట్ డివైజర్స్ ఆఫ్ ఎన్ అంటే ఎన్ని వస్తాయి, టౌ ఎన్. ఎన్ని రెస్ట్రిక్షన్స్ వస్తాయి, 1, 2, 3 అప్ టు ఎన్. సెకండ్ రో అంటే 1, 2, 3, 4 అప్ టు ఎన్, గోయింగ్ ఆన్. ఎంత్ రో అంటే ఎన్ని రెస్ట్రిక్షన్స్ ఉంటాయి, అగైన్ 1, 2, 3 అప్ టు mn, the divisors of n. టోటల్ ఎన్ని అయితే అమ్మా,
M.
సో m into tau n. Tau n plus tau n plus tau n plus tau n up to m plus tau n plus tau n plus tau n plus tau n is nothing but m into tau n. So this is what is the answer. So over real field ante 2 తో మల్టిప్లై అయింది సార్. Is it clear? Is it clear? Hello. So this is very interesting example, very nice example. Okay. Divisors ఎన్ని ఉంటే ఇక్కడ ఎన్ని డివైజర్స్ ఉంటే అన్ని యాక్చువల్ గా మనకి రెస్ట్రిక్షన్స్ వస్తాయి. ఎన్ని ఉంటాయి, టౌ ఆఫ్ ఎన్ని ఉంటాయి అంటే ఫస్ట్ రోకి అన్ని రెస్ట్రిక్షన్స్ వస్తాయి. సెకండ్ రో కూడా అన్ని I equals to 2 పెడితే ఎన్ని రెస్ట్రిక్షన్స్ వస్తాయి, ఎన్ టౌ అన్ని రెస్ట్రిక్షన్స్ వస్తాయి. I equals to 3 పెడితే ఎన్ని రెస్ట్రిక్షన్స్ వస్తాయి, థర్డ్ రోకి ఎన్ని రెస్ట్రిక్షన్స్ వస్తాయి, అగైన్ డివైజర్స్ ఆఫ్ ఎన్ని వస్తాయి. అర్థమవుతుందా? సో రెస్ట్రిక్షన్స్ ఎన్ని ఉంటాయి సమ్ చేయండి, డిలీట్ చేయండి, అయిపోతుంది. టోటల్ వేరియబుల్స్ నుంచి రెస్ట్రిక్షన్ డిలీట్ చేయండి, యూ కెన్ గెట్ ద ఆన్సర్. సపోజ్ యూ టేక్ దిస్, సో కంప్లీట్ చేయాలి 5 minutes only. Suppose you can take this, trace of a equals to 0. This is important for trace of a equals to 0. So what is my dimension of V whenever it is a complex field? What is my dimension of V whenever it is a real field? Tell me. Total variables any mn. What is my restriction? 1. So mn minus 1. What is my dimension of this for a real field? 2 into mn minus this. Okay. Suppose V is my vector space, n by n matrices. ఇక్కడ ట్రేస్ అంటే ఏంటి, యాక్చువల్గా ట్రేస్ యూ నీడ్ టు కంప్యూట్ ఫర్ ఓన్లీ స్క్వేర్ మ్యాట్రిసెస్. ఇక్కడ రాంగ్ రాసాను చూడలేదు, రైట్. n by n is n square minus 1. Trace, one can compute the trace for only square matrices. Into this. So set of all n by n matrices over a complex field such that A transpose, that means symmetric matrices. What is the dimension of V whenever F is my complex field? What is my dimension of this whenever it is a real field? Tell me. Yesterday I told you this technique. Whenever it is a symmetric matrix, that the matrix should be like this. First row, first column should be same. First row, first column should be same. Second row, second column should be same. This is ANN. So distinct variables ఎన్ని ఉన్నాయి, ఫ్రీ వేరియబుల్స్ ఎన్ని ఉన్నాయమ్మా, డయాగోనల్ అబౌవ్ డిస్టింక్టివ్ వేరియబుల్స్. డయాగోనల్ ఏమైతే రిపీట్ అవుతాయి కదా, ఎసాను డయాగోనల్ అబౌవ్ డిస్టింక్టివ్ వేరియబుల్స్. డయాగోనల్ కింద ఏమైతే మళ్ళీ డయాగోనల్ పైన ఉన్నాయి కింద వస్తాయి. కాబట్టి డయాగోనల్ పైన ఉన్నాయి కనుక్కుంటే సరిపోతుంది. డయాగోనల్ పైన ఎన్ని ఉంటాయి, ఫస్ట్ రోల్ ఎన్ని ఉంటాయి, సెకండ్ రోల్ n minus 1 ఉంటాయి. ఇది యాక్చువల్ 1 అవుతాయి. టోటల్ ఏమైతే 1 plus 2 plus 3 plus n. What is this dimension of V? What is this n into n plus 1 by 2? So what is my dimension? N into n plus 1 by 2. రియల్ ఫీల్డ్ అయితే ఏమైంది డబుల్ అయిపోతుంది కదా. సో వాట్ ఈస్ దిస్ n into n plus 1 by 2. Suppose we can take this. What is the skew symmetric matrix? Set of all n by n matrices over a complex field such that A transpose is equals to minus A. Now tell me, what is the dimension of this over a complex field? What is the dimension of V over a real field? Fast, 3 minutes. Hurry up. So what is this? Yesterday I told you that A is a matrix which, yeah, A should be see, it's a skew symmetric means diagonal entries should be 0. First you need to fix this. And A12, A13, A1n. So this is nothing but minus A12 minus A1n. Next, A23, A24, A2n. It's nothing but as it is. So how many entries? Diagonal కింద రిపీట్ అయితే అగైన్ ఈ జీరో కూడా మనకు సంబంధం లేదు, జీరో కూడా మనకు అవసరం లేదు. సో మీదే ఉంటాయమ్మా, ఇది n-1, n-2, 1. సో టోటల్ ఏమైంది 1 plus 2 plus 3 plus n-1. This is nothing but dimension of it. What is this? n into n minus 1 by 2. This is nothing but n into n minus 1 by 2. సో రియల్ ఫీల్డ్ ఏంటైతే డబుల్ అయిపోతుంది. సో బేసిక్ వస్తే ఇవన్నీ ఫాస్ట్ చేయొచ్చు, అర్థమైంది కదా, బేసిక్ ఉండాలి రైట్. Suppose you take the intersection with symmetric and skew symmetric matrices. Symmetric and skew symmetric. My field is complex. What is my dimension? My field is real. Symmetric కావాలి, skew symmetric కావాలంటే ఆ మ్యాట్రిక్స్ ఏమైతే చెప్పండి, జీరో మ్యాట్రిక్స్ అయితే కదా. A transpose equals to minus A, A transpose is equals to A. Therefore by these conditions A equals to minus A. Therefore A must be 0. A must be 0 అంటే V ఏమైతే మ్యాట్రిక్స్ జీరో మ్యాట్రిక్స్. జీరో మ్యాట్రిక్స్ డైమెన్షన్ ఎంత 0. 2 into 0 ఎంత 0. అర్థమైనా? Is it clear? So suppose we take upper triangular matrices. It says upper triangle. Suppose my field is complex. What is the dimension? Suppose my field is real. Now tell me. Upper triangle ante A is upper triangular. A is a matrix means A is upper triangular. A is upper triangular ante A is A0. All the entries below the diagonal are 0. All the entries below the diagonal are 0. This is A11, A12, keep it as it is. A11. A21 is 0. This is A22, A2n. So this is going on, AN. So all the entries below the diagonal are 0. This is 0. So how many free variables in first row? N. How many free variables in second row? N minus 1. How many free variables in nth row? 1. Total sum is 1 plus 2 plus 3 plus n. This is nothing but n into 1 by 2. So what is my dimension? N into n plus 1 by 2. But when you are working with real field, what is this? N into n plus double. Okay. Suppose it is lower triangular. Therefore, n by n matrix is over complex field. A is low triangular. If first subspace అయితే అయితే మనం చెక్ చేసినాం సమ్ ఆఫ్ లో ట్రయాంగులర్ ఇస్ ఆల్వేస్ లో ట్రయాంగులర్ అని గుర్తుంది కదా. సబ్స్పేస్ అయితేనే డైమెన్షన్ ఉంటుంది, వెక్టర్ స్పేస్ అయితేనే డైమెన్షన్ ఉంటుంది, వెక్టర్ స్పేస్ లేకపోతే డైమెన్షన్ ఉండదు. ఫస్ట్ మీరు ఏం చెక్ చేయాలి, ప్రాబ్లం ఏమగానే అది వెక్టర్ స్పేస్ కాదా చెక్ చేయాలి. వెక్టర్ స్పేస్ కాకపోతే అది డైమెన్షన్ ఉండదు. డైమెన్షన్ గురించి మాట్లాడద్దు, ఇక మర్చిపోవాలి. ఓకే, ఇవన్నీ మనం ఆల్రెడీ మ్యాట్రిక్స్ తెలియదు. ఇవన్నీ ఏంటి సమ్ ఆఫ్ లో ట్రయాంగిల్ ఇస్ ఆల్వేస్ లోవర్ ట్రయాంగిల్. Scalar multiple of lower triangle is always lower triangular. Therefore, it is a subspace. Yeah, tell me. Suppose you take A is a matrix which is lower triangular. So all the entries which is above the diagonal are 0. Right? So therefore, what is the form of A? What is the form of A? All the entries above the diagonal are 0. You fix first diagonal entries. These entries are 0. This is what A21. A31, A32, this A33. Going on, AN1, AN2, going on. So how many free variables in first row? Only A11, 1. How many free variables in second row? Only A1, A21, A22, 2. Going on, nth row, n. Total sum n into n plus 1 by 2. This is what dimension. Okay, this is what actually over C, n into n plus 1 by 2. Dimension over R, n into n plus 1 by 2. Okay. Okay, time is almost. Okay, రేపు చెప్తాను ఇంకొక 5-6 రేపటి క్లాస్లో కంప్లీట్ చేద్దాం.